How's doing, guys? It's day 29 from June LeetCode challenge, and today's problem is unique paths. In this problem we will understand the problem definition first, and then we'll try to see the solution for this problem, and at the end we will try to code and understand the time complexity for this problem. Before we proceed, if you are new to the channel, please do subscribe, as we solve a lot of competitive problems. Alright, now let's begin with the problem. Okay, what problem says is a robot is located at the top left corner of M cross N grid, and that is marked as a start in the diagram below. Alright, the robot can move either down or right at any point of time. The robot is trying to reach the bottom right corner of the grid that is marked as a finish in the diagram. So how many possible unique paths are these? Alright, so you have one grid given M cross N, okay, and robot is at a 0 position start, and you would like to reach to the last M cross N position, or M minus 1 N minus 1 position you want to reach. That is a finish line. During traversal you can go either downside or you can go on a right hand side. So from here robot can go on this direction or it can go on this direction. Alright, now let's see the example. So if you have M is equal to 3, N is equal to 2, there are three outputs or three paths possible to reach from here to here. Alright, so what all those threes, robot can go right and down. So one possible combination is right, it can go again right and then down. Alright, the other one is right down right, so it can go right then down and right. Alright, and last one is down, first it will go down and then right. So these are the three combinations can be possible with M is equal to 3 and N is equal to 2. Alright, the next example is M is equal to 7, N is equal to 3. So for that we have total 28 combinations. Now let's understand with different examples, and then we will see the solution for this. Alright, now these are the different M and N combinations I took to understand this more clearly. Alright, now let's say first we have only one cell, that is M also 1 and N is also 1 in the grid. So we have 1 cross 1 grid, and our start and end point, our robot is at the same position. So let's say our start is also here and our end is also here, or finish is also here. So in that case, if you see, we have only one possible combinations to traverse, because we do not need to traverse anywhere, but there is only one path. You stay over there, and that is what the answer you have. Alright, so we have only one path for this solution. Alright, and the second is, let's say you have only one row, your robot is at here and you want to reach at here. So one condition is our robot can go in these two directions, right or down, but as we do not have any other rows, so there is only one way to go, that is go right. Alright, so if there is a one column or if there is a one row only, you have only one path, because we cannot go down. Okay, so if only one row is there, the output number of paths possible combinations can be a 1. If you see, the same goes for the columns also. If you have only one column and your robot is at here, finish line is at here, then it can go only downside. There is no other way to go to the right side. Alright, so for this also we have only one solution, that is going to be only one possible path to start from start and reach to finish. Alright, now if you have M cross N is equal to 2 cross 2 grid, okay, so your start point is here and finish point is here. So here we took multiple rows as well as columns. Alright, and in this case, so one possible combination, I can go right and then go down. This is one possible combination. Second, I can go down from here and then I can go right here. So when you are at a finish line, there are two possible paths for 2 cross 2 grid. Alright, so you know the columns, when there is a one row or one columns, what could be the possible paths. Okay, and you also know if you have multiple columns and multiple rows, how can we reach to that position. So what I'm saying is, for any of the I comma j position, alright, let's say I'm drawing that cell here. So there are possible ways to reach at these cells are either from the top or it can be from the left hand side. Alright, so from the top, that means that cell is going to be your I minus 1 comma j, or this cell could be I comma j minus 1. Alright, so if you know the details of this cell, then I can calculate the I and j, because my I and j is going to be whatever the data you calculated for this cell plus this cell, because we already know how many ways I can reach I minus 1 j and I and j minus 1. Then this is going to be my let's say I'm defining, let's say, two-dimensional matrix, something called dp. So dp of my ij is dependent on dp of your I minus 1 j plus dp of your I j minus 1. Okay, now what all details we have? One thing we know is, I know that initial state for the first row and first column is always going to be 1. So let's say if you have a 3 cross 3 grid and we would like to apply this equation, then how can we fill that equation? How can we fill that grid? Let's say we take m is equal to 3 and n is equal to 3. All right, now this is my start and this is my finish. Okay, so from the above two examples, I clearly knows that the possible path for the, if there is one column and one row is there, then it is going to be always a 1. So my this initial state is always be 1. There is always one way to traverse. All right, now when you are at here, how can I calculate this state? Based on my previous I j minus 1 and this one. So you can do addition of this two. So that is going to be my current state of this ij. So what it says is, if you have only 2 cross 2 grid and this is your end point, then there are total 2 ways to reach at this ij. All right, now same applies over here. So how many ways you can reach over here? 2 from 2 here and 1 from here. So there are total 3 ways to reach over here. Same applies over here. So 3 ways, and 3 plus 3, that is going to be 6 ways to reach over here. So what we are saying here is, let's say if you take how many 3 ways you can reach here. So one is directly you can go and here. Second, you can go here, go down, and then here. Third is go this way and directly this way. All right, so that is how we can get your final state based on the previously calculated state. All right, so it's one of the dynamic programming problem based on the matrix. All right, now let's write down a code for this. All right, so first we will define our matrix of m cross n to just hold the state of different rows and columns. Integer dp it's gonna be m and n. All right, and return we will do is at the end m minus 1 n minus 1 will have our final answer. All right, so that we will return. Okay, so now let's first initialize our rows and columns to the 1, because that is the initial state we know. If you have only 1 rows and 1 columns, so number of ways the path is going to be 1 only. So let's start with that. Integer I is equal to 0, I less than n, I plus plus. All right, dp of your 0 and I. So the first row we will make to 1. Same we will apply for integer I is equal to 0, and then I will go till m I plus plus. All right, and dp of your I. So the first column we will make it to the 1. So we have initialized the initial states of our dp matrix. Now let's iterate from the next cell, that is going to be your I and j is equal to 1 1. So we already initialize for 0 for the first row and first column, I less than m, I plus plus, and my j will start from 1 is equal to 1, j less than n and j plus plus. All right, now dp of my ij, that is going to be my dp of I minus 1 j and dp of I j minus 1. All right, so we have initialized or initiated our new state dp of ij with the dp of I minus 1 j plus dp of I j minus 1. All right, now let's run this code. All right, it got finished. So for 3 cross 2 we have 3 ways as we have seen in the example. All right, now let's submit it. All right, it got submitted. Let's see the memory utilization as well as time execution. Use the dp matrix. All right, the total time complexity was for this problem is going to be m cross n, and space wise also we are utilizing extra space for the dp matrix to hold the different states, so that is going to be also m cross n. So that's it in this video. Hope you like it, guys. If you have a different problem solutions, I would recommend to write it down in the comment. Please like, share and subscribe to the channel. See you in the next video. Till the time, bye bye.